Hello students, let's begin part 2 of this lesson by summarizing slopes in general. So as we learned in part 1, there are 4 general types of slopes. Positive slopes go upward or increase as one increases the other as one increases so does the other. These will all be variations of y equals x, and when you look at them on a graph, you will see that they go upward from left to right. Negative slopes are also variations of y equals x, except they have a negative slope or a negative x value. So you'll see them going downward when you look at them on a graph. Zero slopes are variations of y equals 1. They are linear functions that are represented by horizontal lines. And last, we have undefined slopes. This line here does have a constant rate of change, but it does not have a slope because it's not a linear function. It's a variation of x equals 1 in which x has many outputs depending on where it is. So in other words, when we look at it, it looks like a vertical line. So anytime you see a vertical line, you'll know it has an undefined slope because it's not actually a linear function. Now, we're going to look at how to calculate the exact slope from a graph. Remember, slope is a constant rate of change, and a rate of change is the change in the dependent variable to the change in the independent variable, or the change in y, because dependent and y are synonyms, over the change in x, which stands for the independent variable. And we know on a graph that y goes up and down, so we're going to call that the rise, and we know that x goes left to right, we're going to call that the run. You can remember rise over run because you first have to rise to stand before you can run. So that might be a little bit of a way for you to remember that. Now, to calculate slope on a graph, slope is represented by the letter m. And in your group practice, you'll read why it stands for m. Okay, now, slope, which we're going to call m, is equal to the rise over the run. Start at the leftmost point, which is here at A. Put your pencil on A. Drag your pencil up until it rises or falls to the point where B is. Now count how many you went up. In this case, 1, 2, 3, 4. So we could put positive 4 as the rise. So positive 4 is going to be in the numerator of my ratio. Now how much do you have to go left or right to get to B? So we will run 1, 2, 3 blocks, and it's going to be positive 3 because we went to the right, and we know greater amounts are to the right, so we have positive 4 over 3. Now, since 4 and 3 do not share any common factors, we're just going to leave it say that the slope is 4 over 3 because this will constantly occur across our graph. Up 4 over 3, up 4 over 3, up 4 over 3. Let's look at another example. In this example, we know that our slope is going to be a negative number because see how it's going downward? Okay, so we know our slope is going to be negative, and it's going to end up being the rise value over the run value. So start at our leftmost point, which is in this case A. Are we going to have to rise to get to B? No, we're going to have to fall. So this is where we're going to get our negative value. So we're going down 1, 2, 3, 4, 5, 6. We went down 6. So the rise is negative 6 over, and the run is to the right, so that's positive, and it's 1, 2, 3 numbers, so 3. So we have negative 4 over positive 3. Negative 6 divided by positive 3 is negative 2. Since these two numbers can divide each other, we get negative 2. But really, think about negative 2. Negative 2 is still a ratio over 1. And if you look, we could go down 2 over 1, down 2 over 1, down 2 over 1. It's just that we did that slope 3 times. So in this case, our slope is negative 2, which is the same as negative 2 over 1. Let's look at another example. We're going to do our slope, which is rise over run. In this case, we know that our final answer is going to be negative because we see this graph moving downward. We need to fall 3 blocks, that's our rise, so negative 3. And we need to run 1, 2, 3, 4, 5. So positive 5 because we went to the right. 3 and 5 share no common factors, so our slope is negative because negative divided positive makes a negative, 3 over 5. In other words, down 3 over 5. Let's look at another example. Remember, slope is always rise over run. And in this case, our slope's going to end up being positive because we see this going upward. So we need to rise to get up to be 1, 2, 3, 4, 5, 6 blocks. We went up 6. And we're going to the right, which is positive 2. So our slope is 6 over 2, which will reduce to 3 over 1, or 3. So our slope is 3. And if you look, we could go up 3 over 1, and we'd be here on the graph, and up 3 over 1, and we'd be here on the graph. It's just that we did it twice. Let's look at another example. If you want to pause the video and try it yourself and check with us, that's fine too. So our slope is rise over run, and in this case we know our answer is going to end up being negative because we see the line going downward. So our rise is in this case a fall of negative 1, and a run of 1, 2, 3, 4, positive 4. So our slope is negative 1 over positive 4. Negative divided positive is a negative, that's why we have our negative slope, and 1/4 will not reduce, so we leave it that way. So our slope is negative 1/4, down 1 over 4. Let's do one more example and then we'll look at a real world situation. Now remember, our slope is rise over run. If we start at our leftmost point, do we have to rise any to get to B? No. So our rise is actually equal to 0. And our run is 1, 2, 3, 4, 5. And 0 divided by 5 is 0. So our slope is 0. Now, most of you will get familiar enough to see this is a horizontal line and automatically know horizontal lines have a slope of 0. Now, let's look at one real-world situation, and then we're going to tell what the slope means in context of the problem. So it says, in a town of 1,600 people, the graph below shows the amount of people that remain in town each hour during a hurricane evacuation. Calculate the slope and tell what the slope means in context of the problem. So this graph is describing how many people remain in terms of how many hours have passed. And you can see that we have 2 points on the graph. After 3 hours, there were still 1,200 people, but after 6 hours, there were only 800 people. Now, let's look at how y changed, the change in the dependent, when the x changed. In other words, the rise over the run. Now, on graphs like this, you have to be very careful because they're not counting by ones. So we fell from 1,200 to 800, so that's down 400 people when 3 hours passed. So our rise was negative 400 over 3. Now let's reduce this to a unit rate because it's going to tell us how much 1 hour evacuated. Now 400 divided by 3 is not a whole number, so we'll kind of have to round it to make sense in terms of people. So we had 133.3, so we're going to say negative 133 over 1. Now think about the y stood for. People remaining. So if it's negative 133, that means that 133 people left town okay, because we know they left town because it's decreasing. And the x value is hours, and we have once, that's 1 hour. Left town every hour. So when you're trying to figure out what slope means in context of the problem, label the numerator or your y value with the y, with what y stands for, people remaining. 133 people left, negative 133. And label the x value with the x term, which is 1 hour or every hour. Now, let's summarize what we've learned. We've learned that a rate of change is a ratio that describes the change in the dependent variable to the change in the independent variable. We've also learned that slope is a special rate of change that is constant. In other words, it describes a linear function. We also learned that there are 4 general types of slope. Positive goes upward, negative goes downward, 0 remains constant, and undefined, which is a vertical line, which is not a function at all, and therefore cannot have slope. And to calculate a slope on a graph, we can use rise over run to write a constant rate of change.